They say that if you listen closely inside a high-pressure airgun manufacturing plant, you can almost hear the heartbeat of compressed power waiting to be unleashed. It begins as a whisper, raw metal being shaped into sleek cylinders, polished components, and intricate valves. Yet it grows into something far more commanding. The journey from a simple hunk of metal to a sophisticated air rifle pump is one that most people never get to witness. It's a process veiled behind factory doors, filled with precise engineering, heated debates about legality, and a set of unspoken rules understood by only a select few. Many assume that air rifles are mere toys, overshadowed by the fire and noise of traditional firearms. In reality, certain models push the boundaries of what compressed air can achieve, capable of launching projectiles at velocities that rival and sometimes surpass smaller caliber powder-based guns. Before modern factories streamlined the production process, air-powered weapons went through centuries of refinement, dating back to old designs that used cumbersome bellows or reservoirs. Today, these rifles are leaner, stronger, and more potent than ever before, an evolution that has left regulatory bodies scrambling to categorize and control them. A nondescript building on the outskirts of a busy industrial district might be the last place you'd expect to find advanced pneumatic innovation. Yet, stepping through the doors of such a facility is like entering a hidden domain. An immediate rush of heated air envelops you, thick with the scent of lubricants, molten metal, and that subtle tang of ozone often associated with welding arcs. Workers in protective goggles shuffle between stations, some hunched over manual lathes, others operating computer-controlled cutting machines. Although they move with practiced efficiency, there's a weight in the air, a recognition that any slip can lead to catastrophic consequences. High-pressure systems are not forgiving. The earliest station deals with shaping metal tubes that will become the air reservoirs. Steel rods are sliced into uniform lengths, then fed into machines that bore out their cores. A single misalignment can cause the internal walls to be too thin, risking a blowout when pressures soar. Operators constantly measure with calipers and micrometers, double-checking for the slightest deviation. At the next station, heated metal is hammered or pressed into shape for components like breech blocks, trigger units, and air valves. Though technology has advanced, some tasks remain reliant on human hands and eyes, relying on skilled artisans who've been refining these parts for decades. In a corner of the factory, a design team studies blueprints projected onto large monitors. They're quick to adapt, often retooling parts mid-production to optimize airflow or reduce weight. Word around the plant is that continuous innovation isn't just a corporate slogan, it's a matter of survival. The competition to build the most efficient, accurate, and powerful airgun is fierce, and any new design twist can spark an arms race in the broader industry. Manufacturers keep certain technical breakthroughs under wraps, hoping to maintain a competitive edge. As a result, rumors swirl about who might be testing more potent valves or exotic materials that can handle unprecedented pressure levels. Sometimes the tension in the air has less to do with manufacturing challenges and more to do with the question of how powerful these guns should be allowed to get. While many designs cater to sports enthusiasts, target shooters, small game hunters, and hobbyists, others raise eyebrows for their near-lethal force. Critics argue these high-powered models skirt dangerously close to regulated firearms, and that unscrupulous buyers might exploit them. Stories circulate of seized shipments that found their way onto black markets, or of shady dealers swapping standard components for specialized hot parts that drastically increase muzzle velocity. Factory representatives deny any involvement, insisting that their role ends once the items leave the loading docks. Yet the whispers persist, fueling ongoing debates about where responsibility truly lies. On the factory floor, it's easy to spot the veterans from the newcomers. Seasoned workers have a certain calm about them, an almost intimate familiarity with the hum of pumps and the hiss of escaping air. They'll cradle a newly assembled pump like a prized possession, running a practiced eye over its seams, feeling for invisible vibrations. In a way, these individuals become part of the manufacturing lineage, passing knowledge down to apprentices who begin with menial tasks, sorting screws, operating foot presses, and gradually earn the right to assemble a rifle from start to finish. Not all stories from within these walls are inspiring, though. Lurking underneath the surface is the very real hazard posed by compressed gas. Even minor leaks can lead to sudden drops in performance, prompting reworks, but a major breach at high pressure is a different beast altogether. Workers have recounted hearing a resonant thud, followed by a sharp metallic cry when a cylinder ruptured. No fire, no raging explosion, just an instantaneous release of energy that can fling shards of metal across the workshop. The aftermath is often hushed up to avoid negative press. An entire shift might be sent home early, and safety investigators discreetly document the event. If local authorities get involved, factory owners typically offer them a sanitized version of events, complete with forms that declare every measure was in place. As with any industry that deals in powerful machinery, official guidelines exist. Certain production lines subject to random inspections, especially if the company exports to nations with strict regulations on air weapons. Factories that pass muster might sport certificates proclaiming compliance with international safety standards. But to outsiders, these framed documents can feel like window dressing. Even among staff, it's whispered that you can't truly tame compressed air. It's a constant struggle to keep it under control. That tension pervades every stage of production, from forging the smallest spring to forging the largest reservoir. Despite risks, the pull of this industry remains strong. It's not just about profit. There's an almost cult-like fascination with harnessing air in such a potent form, as if each completed rifle is a testament to a remarkable feat of engineering. Workers speak with pride about prototypes that push beyond normal limits or achieve shockingly tight groupings on the testing range. One older technician, rumored to have worked in the factory since its inception, beams whenever asked about the precision milling process for ballistic-grade barrels. He'll claim you can drop a pellet in one end of a finished barrel, blow lightly, and watch it glide out the other side without the slightest wobble. A perfect alignment. Over by the quality control section, employees wearing thick ear protectors and safety glasses test the assembled rifles. Each one is clamped into a specialized rig, aimed at a reinforced target zone. A series of shots are fired at varying pressure levels to confirm consistency, velocity, and grouping. If any rifle fails to meet standard specs, it's torn down piece by piece to identify the culprit. Sometimes it's as trivial as a deformed O-ring or a microscopic burr that disrupts airflow. Sometimes it's more severe, a defective valve or a flawed reservoir that calls the entire production batch into question. Efficiency is prized. The faster they can isolate problems, the quicker they can recalibrate the manufacturing line. Testing doesn't stop at basic firing trials. Extreme stress exams push the rifles to the brink. Pneumatic pumps are cycled far beyond normal usage to see when and how they fail. Valves are subjected to rapid shifts in temperature, from sweltering heat to freezing conditions, all in the name of ensuring reliability. The most harrowing tests involve overpressurizing the system well beyond normal operating limits to see if the rifle's safety valves respond correctly. Most of the time, they do their job, venting the excess and rendering the device inoperable until repaired. In rarer cases, the entire rig shudders from a sudden pressure spike, prompting engineers to scramble for data logs. Each potential flaw gleaned from these events feeds future design revisions, forming a perpetual feedback loop. A short distance from the main assembly lines, the pump manufacturing area hums with equally intense activity. These pumps are the lifeblood of high-pressure air rifles, the essential link that provides a consistent flow of compressed air. Everything from the pump handle's ergonomic shape to the type of seals used in the piston cylinder can influence final performance. Material science plays a big role. Choose the wrong alloy for the pump shaft, and it might corrode or warp under repeated cycles. Skimp on the seal's quality, and you'll end up with micro leaks that force the user to pump more frequently, undermining the rifle's reliability. Workers in this section often come from backgrounds in machining or automotive repair, bringing with them an innate understanding of how seals and pistons operate under stress. They test each completed pump on a specially calibrated gauge, pumping until they hit the designated PSI, sometimes 3,000, 4,500, or even higher. If a seal so much as whistles with the hint of a leak, the unit is stripped down to its components, inspected, and re-lubricated, sometimes replaced entirely. While the tasks can be repetitive, mistakes here carry huge ramifications for end users counting on that precise air pressure. Stories of near misses filter through the corridors. One widely circulated account claims a newly designed pump spontaneously disassembled during a test, launching a metal rod across the room. No one was injured, but a forklift window wasn't so lucky. Then, there are the whispered allegations that certain factories quietly produce extra high-pressure variants for private clients, never admitting these modifications to regulatory bodies. Enthusiasts who want extreme power allegedly pay a premium, fueling an under-the-table industry that straddles legality in several countries. Company spokespeople deny these rumors, stating that any modifications beyond factory specs void warranties and contravene official regulations. Yet the speculation persists, stoking the mystique of what truly happens behind the factory's locked gates. All the while, the assembly lines maintain their rhythm. Metal components are riveted into place, pump handles are fitted, and final calibrations made. Once a batch is ready to ship, workers pack the rifles and pumps into padded crates. Destination labels might read like a geography lesson, shipping everything from big box retailers in North America to specialized shops in Europe or Asia. The exported items often meet the minimum muzzle velocity limits mandated by the importing nation, but that rarely placates critics who argue these products can be modified with ease. It's a debate that stretches from local legislative halls to global forums. How powerful is too powerful when it comes to air rifles? And who is accountable when they're misused? Factory managers describe themselves as mere suppliers, fulfilling global demand. They insist that safety is their top priority, pointing to training sessions for new hires and posted warning signs. Workers, however, might offer a more nuanced perspective, acknowledging improvements but still seeing gaps. Accidents aren't a daily occurrence, but the possibility remains ever present, seeping into every corner of the plant. Whispered tales of hush money or intimidation also lurk in the background, especially when discussing serious mishaps. In the broader societal context, air rifles inhabit a unique niche. Traditional gun advocates sometimes dismiss them as lesser imitations, while strict gun control supporters worry they form a loophole for restricted weaponry. Sport shooters champion their accuracy and relative affordability, with some top-tier models capable of felling small to medium game. Like many technological advancements, the moral weight rests on how these tools are used. The factory environment amplifies this ambiguity. The same engineering that yields a precision target rifle can also push into realms that blur lines with regulated firearms. Regulations vary wildly. In some regions, high-powered air rifles fall under the same stringent rules as conventional guns, requiring background checks and licensing. In others, they're seen as little more than elaborate pellet guns. Manufacturers keep a close eye on legislative changes, wary of sudden shifts that could cripple markets. A rumored proposal in one major importing country might force them to redesign entire product lines, adding safety mechanisms and restricting potential muzzle energy. Yet, for every new restriction, there's a wave of hobbyists who claim such constraints punish legitimate enthusiasts without addressing illegal modifications or smuggling. Outside the facility, passers-by might see pallets loaded into waiting trucks, oblivious to the internal complexities that produce them. Inside, though, the mood swings between pride in technical mastery and unease about what the future holds. Sometimes engineers from rival companies are spotted lurking at the gates, trying to glean trade secrets or confirm rumors of a groundbreaking new design. Sometimes local officials drop by for a casual visit, leaving managers scrambling to ensure every station looks compliant. The daily push and pull is as much about optics and reputation as it is about production metrics. When the final whistle sounds and workers peel off their gloves and aprons, they file out into the night with a mixture of relief and lingering adrenaline. The clang of metal fades, replaced by the chatter of colleagues comparing notes on the day's tasks. Some commute long distances to get home, so exhausted they can barely stay awake. Others stop by roadside tea stalls, reliving tense moments when a valve jammed or an air reservoir showed unexpected stress lines. A sense of camaraderie forms in these late-night gatherings, uniting them in the shared knowledge that each shift is a dance with the forces of pressure and engineering. Those who stay longer, perhaps for the overnight maintenance shift, see the factory in a different light. Machinery is powered down, and only the humming of compressors remains, as they can't be fully turned off without risking condensation or vacuum lock. Under dim emergency lighting, silhouettes of half-assembled rifles stand as silent sentinels. It's a reminder that, come morning, the gears will spin again, forging new lines of hardware meant for markets far and wide. Controversy or not, the appetite for high-pressure airguns continues to expand. Fans adore the silent precision and the mechanical elegance, whereas detractors fear the potential for lethal misuse. Meanwhile, the manufacturers navigate a labyrinth of engineering challenges, safety protocols, and evolving regulations. On the horizon loom questions about whether to embed new electronics into these weapons, adding digital pressure gauges or built-in ballistic calculators. Purists scoff at the idea, insisting that such bells and whistles distract from the simple, timeless appeal of compressing air in a tube to propel a projectile. At times, it feels like the story of these rifles is as much about human ambition as it is about mechanical prowess. The relentless quest for more power, better accuracy, and refined craftsmanship parallels humanity's broader drive to stretch the boundaries of what's possible. Just as each new model aims to best its predecessor, so do the controversies swirl ever higher, prompting bigger questions about innovation, responsibility, and the cost of progress. For every confident statement from a company spokesperson, there's a cautionary tale whispered among operators who've witnessed firsthand the destructive potential lurking within a flawed or overcharged rifle. Stroll through an international sporting event, and you might find shooters boasting about a custom-tuned air rifle from this very factory, praising its immaculate barrel alignment or the fluid motion of its bolt. Few realize the months of trial and error, the near misses, and the dogged perseverance behind that final masterpiece. When they squeeze the trigger and watch the pellet punch a precise hole in a distant target, they're seeing the end of a long, complex chain of decisions and labor. Step into a rural hunting cabin, and you may find a father teaching his child how to responsibly handle an air rifle, extolling its benefits over more traditional firearms. Unbeknownst to them, the pump they're using has a lineage that includes intense calibration sessions, factory debates over seal materials, and perhaps even the quiet resolution of a safety flaw. Every hiss of compression stands atop a foundation of real-world engineering that's rarely discussed in daily life. As the market grows, concerns pile up too. High-pressure air rifles are becoming increasingly accessible online. Some platforms once considered them harmless, lumping them in with paintball markers or toy pellet guns. But with rising muzzle energies come calls for stricter oversight, demands that sometimes clash with the freedoms cherished by sportsmen and collectors. Meanwhile, factories must adapt or risk being left behind. Skilled labor is in short supply and wages inch upward as experienced technicians realize their worth. The best employees learn to navigate both the mechanical intricacies and the political minefields swirling around the industry. Each year, new faces arrive, hoping to break into this specialized world, only to discover that the job is far more complex than simply assembling parts. Beyond the daily grind of forging and testing, there's a growing conversation about sustainability. Traditional metal forging consumes significant energy and generates waste. Some innovators propose using advanced composites or 3D printed alloys to lighten rifles and reduce production costs. While the old guard remains skeptical, a new generation of engineers sees this as the next logical step in pushing boundaries. From the vantage point of a planet grappling with resource limitations, the shift seems inevitable, yet it also raises new hurdles in recycling and repair. The industry, after all, thrives on a balance of tradition and progress, and any abrupt change can reverberate through supply chains and product lines. In hushed corners of the internet, sensational headlines claim that some high-pressure air rifles are being tested for uses far beyond target shooting. Borderline militarized adaptations perhaps, or specialized roles in pest control that verge on ethically questionable. While factory management usually dismisses such stories as outlandish rumors, the line between rumor and reality can blur. Independent tinkerers post videos demonstrating how minor tweaks yield alarming performance gains. Factory insiders bristle at the negative attention, yet they can't deny the widespread culture of modification that feeds off these weapons' inherently customizable nature. The word pump might conjure an image of a simple lever, but in advanced air rifle design, it becomes a crucial piece of specialized hardware, enabling portable recharging without heavy tanks or compressors. The pump's design reflects the entire ethos of the facility. It must be efficient, rugged, and capable of withstanding thousands of cycles at punishing pressures. Its handle has to be ergonomic enough to avoid injuring the operator's arm during repeated strokes. Its internal seals need to endure rapid temperature changes from friction. Each movement of that handle condenses air from the environment into a tightly packed force, forging a bond between man and mechanism that's as old as the concept of harnessing energy itself. Walk the corridors of this factory and you'll come upon storerooms filled with partially assembled rifles, bins of springs and O-rings, and spools of metal wire for reinforcing key stress points. No matter how advanced the technology becomes, there's still a distinctly mechanical heart beating at the core of these systems. People from all backgrounds work here. Mechanical engineers, quality inspectors, machinists, and even chemists who study the molecular properties of lubricants. Combined, their efforts transform raw metals and polymers into sophisticated instruments capable of impressive feats, and sometimes stirring debate. As day blends into night, the tempo of production never fully stops. Shifts rotate, ensuring that the foundry, assembly, and testing phases remain in near constant operation. Each finished rifle or pump emerges like a small miracle of collaborative effort, a testament to the intangible synergy between human ingenuity and the raw power of compressed air. Outside these walls, the controversies, regulations, and rumors swirl in a storm of speculation. But inside, it all comes down to metal, valves, and precision. Will these factories eventually adopt higher levels of automation, rendering many manual positions obsolete? Or will the need for skilled human oversight remain critical as the rifles become even more complex? Some say the future belongs to robotic arms that can weld microscopic seams at speeds no human could match. Others believe the human touch, especially in fine-tuning triggers and calibrating valves, can never be fully replaced. Regardless, change looms on the horizon, promised by new materials, new designs, and a global market that shows no sign of shrinking.